Hi everyone. In this lecture series, we are going to see about the I/O interfacing, that is memory and I/O interfacing. What is the purpose of the memory? So, we are going to store the programs and the data. So, while coming to that of the memory, we are having the processor, primary or main memory. Another one is we are having the secondary memory. So, in the processor memory, we are having the register inside the microcomputer and it is used to store the data and the results temporarily. So there will be no speed disparity and the cost will be increased. While coming to that of the main memory, so what happens, it can be directly accessed, the storage can be directly accessed by the microprocessor, and it is used to store the programs and the data prior to the execution, and it should not have the speed disparity with the processor. Semiconductor memory is using CMOS technology. We are having ROM, EEPROM, static RAM. Another one is the dynamic RAM. The last one is the secondary memory. So we are having the storage media compromising of slow devices such as the magnetic tapes and the disks. It is used to hold the large data files and the programs, operating system, compilers, database, permanent programs, etc. So these are all the memory organization in 8086. So here it is a byte oriented, it is a 16-bit and it is used to store the two consecutive memory location for both the least significant and the most significant. The address of the word and the address of the LSB that has been addressed in the memory bank. So we are having the data bus, BHE address bus. It is divided into odd addressed memory bank. Another one is the even addressed memory bank. This is the memory organization. So we are considering the data lines used from D7 to D0 and D8 to D15. So what are all the even address and the odd address that has been mentioned and how it is transferred. The memory organization in 8086. So the available memory space is EEPROM plus RAM. Allot equal address space in odd and even bank for both EEPROM and RAM. It can be implemented in two ICs, one for even and another for odd in the multiple ICs. So we are interfacing SRAM and the EEPROM. Memory interface is equal to, we are going to read from and write into the set of the semiconductor memory IC chip, and it is EEPROM, it is used for the read operations. RAM, it is used to read and write. In order to perform the read and write operation, the memory access time will be less than that of the read write, and the processor chip select will has to be generated. There will be control signals for read and write operation. We are going to allot address for each memory locations. So here we are having the number of address pins and the range of the address in hexa, and how the memory capacity that has been involved in the decimal in kilo and in hexa. So we are going to interface the SRAM with the EEPROM, that is static RAM. We are having the address bus, VCC, ground. Apart from that, we are having the chip select, read and the write. So how we are what are all the things that has been bidirectional, that is data bus. So here we are going to interface the SRAM and EEPROM with the vector table. So here we are considering the two address spaces. One is even, another one is odd. The KB allocated, this will be 512. So on the memory capacity here we are addressing as 0002 FFFF. So the interrupt vector table that has been available from 4 zeros to 4 F. So here the RAM, the RAM are mapped at the beginning, and that has been allocated, and it has been allocated and it has been allocated at the beginning. At the same time, the value has been allocated to that of the RAM. So here we are having some of the devices, that is programmable keyboard display controller, DMA controller, programmable interrupt controller. Another one is programmable peripheral interface. So here we are going to program all those devices in terms of the initialization of stack, display a message on display, and initializing vector table. So these are all the IO and peripheral devices. So for communication between microprocessor and the outside the world, we are having the keyboard, CRT displays, printer, compact disc, how the ports that's been connected in between the microprocessor and IO devices, what are all the program IO driven, interrupt IO driven, and how it can be accessed with the help of the memory mapped and the IO mapped. So these are all the comparison between the memory mapping and the IO mapping. The data can be moved from the end register to ports, and but in case of the IO mapping, it will be between accumulator and ports. So here it is useful for only the small system. It is used for the system which requires the capacity. Thank you.